On October 4, 2025, NASA's Perseverance rover snapped a photo that immediately drew attention from the scientific community. In the image, a thin, bright streak cuts across the dark Martian sky. And while, at first glance, it might seem like a passing meteor or imaging artifact, the timing and direction of this object matched those of the recently discovered interstellar object, 3I Atlas, as it passed near Mars. This may be the first ever ground-level image of an interstellar object captured from another planet. The streak appears in a composite image generated by NASA's Perseverance rover. This composite wasn't taken in one shot, it was built from a sequence of individual frames, each captured with an exposure time of approximately 3.28 seconds. Over the course of several minutes, the camera took multiple shots of the same patch of sky. When these were later stacked together into a single image, any object that was moving, even slowly, would appear as a linear trail, rather than a stationary point of light. That's exactly what shows up in the final image, a faint, bright, straight line cutting across the Martian night sky. This line is too sharp to be a sensor artifact, and too straight to be a random glitch. NASA has not yet issued an official confirmation that this streak is 3I Atlas. However, the alignment of facts is compelling. According to astronomical models, 3I Atlas made its closest approach to Mars on October 3, 2025, passing at a distance of about 18.6 million miles. That's close enough for a high-sensitivity camera to detect it in the sky, especially in the thin, clear Martian atmosphere where light pollution is virtually non-existent. And the exact time and angle of the streak in Perseverance's image closely matched the predicted location of 3I Atlas at that very moment. In other words, while it hasn't been confirmed with 100% certainty, all available data strongly suggests that the streak in the image is not random, and that Perseverance may have unintentionally recorded the first ever planetary image of an interstellar object. There are several key reasons why many scientists believe the object captured in the Perseverance rover's NavCam image is likely to be 3I Atlas. First, the timing is exact. The photo was taken on October 4, 2025, just hours after 3I Atlas made its closest approach to Mars, estimated at a distance of about 18.6 million miles. NASA had already acknowledged that Perseverance would attempt to observe the interstellar object during this flyby if visibility and conditions allowed. The alignment between the image timestamp and the predicted trajectory window is too close to dismiss as a coincidence. Second, the direction of the streak in the image corresponds directly with the comet's expected position in the Martian sky at that time. Orbital models projected where 3I Atlas would appear from the rover's vantage point, and the streak lines up nearly perfectly with those models. This strengthens the likelihood that the object was indeed captured in motion across multiple frames. Third, the physical appearance of the streak, its shape, length, and brightness, matches what astronomers would expect from an object moving through space during a long imaging session. The image is a composite, constructed from a series of consecutive 3.28-second exposures. A stationary object, like a star, would appear as a dot in each exposure, but a fast-moving body like 3I Atlas would shift position slightly between each frame, creating a stretched trail when the images are stacked. Harvard astrophysicist Avi Loeb, who has studied interstellar objects in depth, explained that the stripe in the image is a natural result of this imaging technique. According to Loeb, in a single frame, 3I Atlas would have appeared as a faint point, but with motion across stacked exposures, the image reveals a clear streak, evidence of its passage through the Martian sky. One of the most striking features of 3I Atlas is its chemical composition, and it's this detail that immediately sets it apart from typical comets found in our own solar system. When the James Webb Space Telescope observed the object in early August 2025, it detected a coma dominated by carbon dioxide, CO2, rather than the more common water vapor, H2O. This in itself is unusual, but what shocked researchers was the exact ratio. The measured CO2 to H2O ratio was approximately 7.6, meaning there was over 7 times more carbon dioxide than water vapor. For context, most comets observed at similar distances from the Sun tend to have CO2/H2O ratios closer to 0.5 or 1.0. This makes the 3I Atlas ratio one of the highest ever recorded in any known comet. What could cause this? There are two leading explanations. First, 3I Atlas may have formed near the CO2 ice line in its original star system. This is the region where carbon dioxide freezes into solid ice while water remains gaseous. If the comet originated from that part of its system, it would naturally carry more frozen carbon dioxide than water. Second, the comet's surface may be coated in a thick, insulating crust. This crust could prevent sunlight from penetrating deeply enough to release water vapor trapped beneath. In this case, only carbon dioxide closer to the surface would be escaping. Either way, the composition strongly supports its interstellar origin and makes 3I Atlas chemically unlike anything typically seen in the solar system. If you're enjoying the video so far, make sure to subscribe to the channel and turn on notifications for more interesting space updates. At the time the image was taken and quietly made public, NASA was under a partial government shutdown. This affected not only internal operations, but also the availability of public-facing communications. Many NASA employees, including members of the public affairs and media outreach teams, were officially furloughed, meaning they were prohibited from working, even voluntarily. As a result, press releases, real-time confirmations, and mission commentary were largely absent from NASA's official channels during this critical observation window. Because of this timing, the image showing the mysterious streak in the Martian night sky was not accompanied by any formal explanation or confirmation from the agency. There was no official blog post, no analyst commentary, and no public response addressing whether or not this image was indeed a sighting of interstellar comet 3I Atlas. However, prior to the shutdown, the Jet Propulsion Laboratory had publicly acknowledged that Perseverance was one of the platforms being prepared to observe 3I Atlas, if conditions allowed. In addition to Perseverance, other spacecraft were positioned to assist with the observation campaign, including NASA's Mars Reconnaissance Orbiter, the European Space Agency's Mars Express, and the Trace Gas Orbiter. These missions were part of a coordinated effort between NASA and ESA to study the comet from both orbit and ground perspectives as it passed close to Mars. In the coming days and weeks, NASA scientists and independent astronomers are expected to carry out a detailed forensic analysis of the image to determine whether the object captured by Perseverance is truly 3I Atlas. First, researchers will recheck the image's metadata, including timestamps, exposure durations, and camera orientation at the time the photo was taken. Even a slight misalignment in timing could shift the perceived trajectory of the object in question. Next, they'll run trajectory simulations, projecting where 3I Atlas should have appeared from Perseverance's location on Mars at that specific time. These models rely on accurate orbital data and account for camera field of view and exposure overlap. They'll also analyze the rover's camera tilt, azimuth, and elevation, matching it against the known path of the comet in the Martian sky. Any deviation between the two will be scrutinized. Finally, experts will examine adjacent image frames, both before and after the main shot, to see if the streak continues or reappears elsewhere. Until this full analysis is complete, the image remains a compelling candidate, but not yet officially confirmed as a Martian capture of 3I Atlas. The European Space Agency's orbiters were expected to observe the comet from Mars orbit. It is possible that in the coming days, ESA may release orbital imagery of 3I Atlas, possibly providing multi-angle confirmation of the object's appearance and behavior near Mars. Additionally, instruments like JWST, Hubble, and even TSS may contribute to long-distance follow-up imaging as the object continues outbound. However, Mars remains our best observation point due to the comet's proximity during its pass. What makes this moment extraordinary is not just that the object is passing through our solar system, it's that we may have captured it from the surface of another planet. Until now, interstellar objects like Oumuamua and 2I Borisov have only been tracked through Earth-based telescopes and distant orbiters. But this may be the first direct planetary observation. Its hyperbolic trajectory confirms that it originated from beyond the solar system, and its unusually high carbon dioxide content, detected earlier by the James Webb Space Telescope, places it among the most chemically distinct comets ever observed. If confirmed, this image will represent a landmark in planetary science and interstellar observation, showing that we can now monitor deep space visitors not only from Earth, but from other worlds. This isn't just a photo. It's a doorway into the interstellar era of planetary observation. Do you think this was really 3I Atlas streaking through the Martian sky, or just a fortunate coincidence? Let us know in the comments, and make sure you're subscribed with notifications on, because this story is just beginning, and you won't want to miss what happens next. Do you want me to also apply quotation marks to rhetorical questions and sentences like "this isn't just a photo" throughout your future documents automatically, or only to technical/scientific phrases?